All right, so this will give us 3 times my integral. And then I'm going to go ahead and put that integral of 4. And then the integral from -2 to 1 of 4 dx is simply going to be 4x evaluated from -2 to 1, which gives me 12. So we have the integral from -2 to 1 dx, don't forget your dx, plus 12. All right, so this is as far as I can go without using u substitution. So I'm going to go ahead and use my u substitution right now, and I'm going to let 2x plus 1 be equal to u. So we get that u equals 2x plus 1, which means that du dx is equal to 2. Or in other words, dx equals du times 1/2. So I'm going to rewrite this integral. Now, the bounds on our integral are -2 to 1 when we're looking at x values. So if we want to rewrite this with u substitution, I'm going to leave my bounds for a second. So f of 2x plus 1 is f of u. Dx is now equal to du times 1/2. Now, our bounds on our integral are from -2 to 1 for x values. So I'm going to plug that in for my u substitution right here. So an x value of -2 means 2 times -2 plus 1. U value would be -3. If I look at an x value on my upper bound, which is 1, that gives me a u value of +3. Okay. Now I'm just going to take that constant of 1/2 in my integral and put it outside of my equation. All right, so we have the integral from -3 to +3 of f of u. Now, this is actually really easy to do from here because the integral is simply the area under the curve. And with bounds of -3 to +3, I actually have my exact areas from -3 to +3. Now, they said that A and B were 5 and 4. All right. So I have positive areas A, C, and D, and then I have a negative area of B. So if I'm looking from -3 to +3, and I'm looking at the integral, I'm just going to use those areas that were given to me. So we have 3/2 of, we had a positive area of 5, negative area of 4, positive area of 5 again, and a positive area of 3. And if I evaluate all of that, I get 25.5 or 25.5. All right. So all of this is our sample response to our free response question for the Calc AB AP test. A, B, C, and D.